Hello guys, welcome to another video. Today we are going to solve a question that is next permutation. So basically the question says that you have to find the next permutation of the given sequence. So let's see the example that you are given a sequence 1, 2, 3 and the next sequence lexicographical sequence is 1, 3, 2. For 3, 2, 1 there is no lexicographical sequence, so it is the reverse of it 1, 2, 3. In next example, nums 115, the next lexicographical output is 151. Here, what I mean by lexicographical order is, it is like a dictionary where you will find every sequence in ascending order. Example, A, B, C, D will come first. Then after that, A, B, D, C. This will come. After that, A, C, B, D. After that, A, C, D, B. So this is lexicographical order where everything is going in the ascending order. Now, how can we find the next lexicographical order here? So next lexicographical order can be found in two ways. One is brute force. So let's look at the brute force approach here, which basically says that find all lexicographical orders in the sequence and match what is the sequence of lexicographical order that you are given, and whatever is the next lexicographical order in the ascending list, just take as output, but that will be approx factorial of n. That is too long of a time, so this time complexity is not needed. So what is the optimal solution that we can do here? So the optimal solution is like this. So basically, let's take the first example, this one. So 1 is here, then 2 is here, and then 3 is here. This is the graph of 1, 2, 3. Now let's look this one. 3 is here, 2 is here, and 1 is here. This is the input. And what is the output here? 1, 3, and 2. What is the output here? 1, 3, 1, 2, and 3. This is the output here. So by observing this graph, we can say that the last highest position is actually replaced by the last lowest position. So they are interchanged here. You can see this is 1, this is 2, and this is 3. So 1, 3, 2. This is how it becomes. And if we apply this in this graph 3, 2, 1, we cannot see 1 is less than 2, 2 is less than 3, but there is no node that is less than the previous node. So there is no node that can actually satisfy this condition, and we cannot swap. When we cannot swap, we just reverse this whole, and by reversing this whole we got 1, 2, and 3. Now let's see a bigger example because there is a catch. So let's say this is the input that you are given. So you will go from this position to higher position and check if 2 is less than 4, yes. 4 is less than 5, yes. 5 is less than 6, yes. 6 is less than 7, yes. 7 is less than 3, no. This condition doesn't satisfy. So you will stop your pointer here. Now you will find another position that is just bigger than this number. So we started from here. Is 2 greater than or equal to 3? No. Is 4 greater than equal to 3? Yes, it is. So we found the replacement here. We will swap these two boys here. So it will become 1, 2, 4, 7, 6, 5, 3, 2. You just found the replacement for the next lexicographical order. But when you see, this is not actually the minimum of that all. So what you need to do is, you need to reverse this. After reversing it, what you will get is 2, 3, 5, 6, 7. And this is the next lexicographical element that you needed. So the optimal solution says that you have to start from the end and you have to go to the left side and check if there is a condition where ith element is actually less than I plus 1. If there is a condition like this, then you have found your first element in the series that needs to be replaced. But now you need to find the another element where the element needs to be replaced by which element. So now we will start from end again, and we will check which element is actually greater than or equal to I. When we found this element, that is basically j, we will swap I and j with each other. After when we swap these two elements, wherever the j element is, you need to reverse the whole series, that is after j, then you will get the lexicographical order element. This is the question at Leetcode. Now we will solve this. For next permutation, like I said, first we will start from the right side, mean the end of the array. So we need to find first the length of the array so that we can start from the end. So int n is basically the nums dot length. So if we want the length of the array, so this is not basically the end of the array, and the end of the array is n minus 1. But here we need the index from where we need to start. We start from the index which is basically one less than the end of the index. Basically what I mean is minus 2, meaning the second last index. So now we need to check if there is some element which is not satisfying this condition. What is the condition? That I should be greater than equal to 0, and then I also not I. Basically the nums of I, the element that we are checking, I plus 1 is the element that we need to check, that is I plus 1. This needs to be, if this is smaller and equal to the element that is nums I, then we know that this doesn't satisfy the condition that nums of I should be less than nums of I plus 1. So what we will do here is we will do I minus minus. Here in this condition we are sure that we are checking for if I is greater than 0. Yes, it is greater than 0. And if number I nums of I plus 1 is actually smaller than I, we are just going in the left direction, because this doesn't satisfy our condition that we need an element that should be less than I plus 1. So if we find an element, then I should be greater than 0. If the I is greater than equal to 0, then we are sure that we have found one element that is actually smaller than the last element. Now what we will do here is we need to find another element that is actually greater, means greater than actually the number that we have got in the place of I. So we will start from the last element and we will check while we need to just find the element that is just bigger than I. So J should be greater than I, of course. We don't want another element here. And then we need also to be sure that so nums of I should be less than nums of J. Till then we are doing J minus minus. Till nums of I is greater than nums of J, we are going to do J minus minus till J is actually bigger than I. After we have done this, we need to swap out nums of I and j. So it is I and j. After it is swapped out, we need to reverse whole everything. Reverse nums, and from where we need to reverse I plus 1. Why I plus 1? Here in the condition, if I is actually not equal to 0 or not greater than 0, then it is minus 1. Then in that condition we need to start from the 0th place. If there is a I that we encountered that is actually less than the previous element, then we need to start from the next element of that ith place to reverse the whole array. Now we will create those two functions that we required, that is actually reverse and swap. I have already done this in the previous video where I have showed you the best way to reverse an array and also showed you how to swap out. So you can check those videos. I think this should run now. Let's check. Okay, so we haven't declared I. So we will be declaring I here. I is basically n minus 2, and let's run again. Okay, so we have not declared j also, so that is also a problem now. Okay, so it has passed, and let's submit this. So according to this, we have done some mistake in the code, and looks like this condition is wrong. So we will just replace it, and it should be greater than equal. Now let's submit this code and check. Okay, it has passed. So let's meet in the next video. Also share this video as much as possible so that I can make new videos for you just like this. Also like, subscribe to my channel. Thank you guys.